Hi, I'm Carl Ford. I'm here with Brittany Nader and Mark Josephson, and we're talking about Coris monitoring and how it takes advantage of the cloud to bring in alerts and alarms from various equipment in customers' networks, be that in construction, uh, hospital environments, pharmaceuticals. Um, you guys have been doing museums, high value assets, and you'd be good for agriculture and a few other things. But more importantly than that, today is showing you how the back end system works and what advantage it gives you in what people call data logging. So, Mark, how about we start off from there?
Great. So what I'd first like to do is give a quick overview of the components and how they communicate and what they do and so forth. So on the left side of the screen, we have a series of different types of sensors. Course currently has 15 to 20 different types of sensors, but most commonly it's temperature that is the key one that we do. So we have a couple different sensors for different temperature ranges. On the top left, we have a device called the ETS, Extreme Temperature Sensor, because it'll go from minus 250 Celsius to positive 250 Celsius. So we use that mostly for liquid nitrogen tanks and minus 80 ULT freezers. Down at the bottom left, we have a smaller battery operated sensor that is good for minus 40 Celsius to plus 80 Celsius. And so we use that mostly for minus 20 freezers, plus for refrigerators, for ambient conditions, sometimes for incubators, and anything that's in that temperature range. In the middle, this is another one that does both temperature and humidity, but it also does light. We have several customers who have animal labs, and it's important to make sure that the lights are turned off at night. Otherwise, it disrupts the cycles and the behavior of the animals. And so we will offer warnings that hey, the lights are on when they're or off when they're not supposed to be. So we have these different sensors, and what they have in common is they all transmit readings. They take readings of whatever type of sensor it is and transmit them to a central device we call a gateway. Think of it like a Wi-Fi hub or something like that. The difference is instead of using Wi-Fi or Bluetooth or some of the more common ones, we use a low frequency wireless method called LoRaWAN, LORA WAN, and LoRa stands for long range. Outdoors, it's supposed to go 10 miles. But indoors, where most of our applications are, it goes through several walls and several floors of a building. We have a couple hospitals that it'll go up and down 8 to 10 floors in a hospital to get to freezers and refrigerators and incubators and so forth that are on different floors or scattered throughout the building. So typically you have one central device, we call that a gateway, that will communicate with 50 to 100 sensors in the building. That has an Ethernet connection. You see the yellow cable, and it then is connected to a port, Ethernet port that'll get to the internet. And what the gateway does is it receives these wireless signals, which has the temperature readings or the different sensor readings, and it forwards them to our servers in the cloud. We're using the Google Cloud. It's been working extremely well for the last 7 or 8 years for us. We were early adopter in the cloud, and that servers. Two things happen right away. One, as soon as a sensor reading hits the cloud, we log it permanently. We never throw anything away. We keep everything forever. I think we have some temperature sensors that we have the history going back about 17 years on a couple of early hospital accounts. Number two, and probably more important for most customers, is we're doing a real-time analysis of these readings as they come in. So if it's a temperature reading, and it's for a minus 80 freezer. Let's say we've set upper and lower boundaries for alert thresholds. And if that temperature comes in above that threshold, say it comes in at like minus 70, then we're going to start notifying people. We call that an alert. And we send out alerts from the servers by text message, by email, by phone call, by all three. Each user chooses how they want to receive that. And they can have one. Most people take text messages, but a lot of people also want to get a phone call if it's really serious. We also have an alert escalation procedure where we will send out different alerts based on the severity and how far out of range the readings are. You don't have to do that, but we recommend that that's a good way of finding out that you're having a worsening problem. Because we keep everything, you can log in at any time to the servers through user account and get real-time access to what the current temperatures are, current temperature readings, and so forth. You can also look at the history and say, you know, what's that freezer been doing for the last couple of weeks, or maybe last year. As long as the system's been installed, you can go back to the very beginning and retrieve every single reading that it was ever sent in. We have a report writer also. We have several customers that use this to generate reports automatically. And you can have as many reports as you want with different groups of sensors and freezers and fridges included in the report. And that report writer can be set up automated, so it automatically sends you a new report every day or every week or every month or whatever, or every year, whatever, and so forth. And then we have some tools I'll get into later for how to optimize these upper and lower boundaries for the sensors for setting off the alerts. So that's the quick overview. Let me get into the user interface. And so this is a small thing we set up for demonstration. And what it shows is we have just 4 different sensors that are working. One, there's a small freezer. It's currently at minus 18.2 degrees. We have a CO2 sensor that's monitoring CO2 levels. This is especially important for people who deal with dry ice, because dry ice turns directly into CO2. And in a small laboratory room or something like that, you want to make sure that the CO2 concentration doesn't get too high, because people can pass out. Quite dangerous. Then a sensor in a refrigerator, and then a larger test freezer that we use for calibrating sensors and so forth. And I can get a look at signal strength anytime I want. But let me show you the key to the system is to set up these alert values. So let's take a look at, say, the minus 20 freezer alert. So this right now, this alert, it's called minus 20 freezer too warm. You can give it any name you want, but you want it to be self-explanatory. So if you get an alert in the middle of the night, you know exactly what it's about. And then you have names of these 2 different freezers. One's minus 18, the other's at minus 17. And then what we've done is we've set up 3 different levels of problem based on severity. So first level this is the first condition under which we want to be modified. It says, hey, if it gets too warm, if it gets warmer than minus 15 Celsius for more than 20 minutes, send out alerts. And then if it gets worse than that, let's say it gets down to this level, it gets down to minus 11 for 20 minutes, send out another alert, now called a definite problem. And then the third level is if it gets to minus 8 for more than 20 minutes, let's do that. And maybe what I want to do is, instead of 20 minutes, let me make that 5 minutes. So I'm going to save that. And so for now on, we'll get to this thing if the temperature is warmer than minus 8 for more than 5 minutes. And so each of these can be set to any level you want, any number of degrees and any time interval. I can go in and make that, let's say I want to make that 12 minutes. I can make these changes. So now I've done that. So this is the heart of the system to take a look at the threshold. So let me show you the tool we use. This helps you take a look. So it says, okay, these are the 2 sensors currently looking at it. It automatically goes back 2 weeks. But I can go back. Maybe I don't want to go back a full 2 weeks. Let's go back to, say, the 6th. And this is midnight tonight. So today's the 15th of August. So at midnight, it turns to the 16th. So that's midnight tonight. And current threshold is 5 degrees, 20 minutes. And so let's take a look. And so what it's going to do is, since we've been recording all the temperatures, you can see these are the overlapping temperatures. And what I can do with my mouse is I can click and drag a little bit to the right, and I can zoom in. And now let me show you a little more. You can see these are the individual readings. We're taking reading every couple of minutes. So you can see these individual readings. And as I move, you can see that. And look at here, there's the threshold. And at this point, it just hit the threshold for one reading and then went back down. So it wasn't, remember, right now, which says, hey, if it's greater than minus 15 for more than 20 minutes, issue alert. Well, it was for 2 minutes. It was warmer than that. So it did not issue an alert. Well, what if we change that? Let's go and let's change the threshold So let's take a look at how we want to evaluate whether these are the proper thresholds. If I click on this symbol, it pops up. These are the two sensors or freezers that are actually being monitored. It goes back, automatically goes back 2 weeks, but I don't have to go back 2 weeks. Let's go back to, say, the 8th. And let's go to about 7 p.m. today. Right now, it's set up to set an alert if it's too warm, if it's greater than minus 15 Celsius for 20 minutes. So let's do some graphs and take a look at that. So here is the actual readings. And if I click with my mouse and zoom in a little more, you can see this. And you can see that the temperature is going up and down in both of these two freezers, basically when the compressor is turning on and off. So that you get a low point and then the compressor turns off. It slowly rises again, and it reaches the threshold, it turns on the compressor, which cools it off again, and so you get this sawtooth pattern. And sawtooth is good because that means your freezer is working properly. But if you take a look, we barely hit the threshold just once, right in there. And these are the individual readings. Remember, every couple minutes we're taking a reading. So these dots represent the individual readings. So this one above the threshold. Well, let's say I want to make it a little more sensitive. So I go here and say, what if we make that, let's say minus 18, no, minus 17. Let's say, and then instead of 20 minutes, let's make it like 10 minutes. Oh, let's make it 5 minutes. And so this is a way to try out changing these alert thresholds. Well, look, this is all red. So this red means alerts were sent out. And let me zoom in a little more. And so what you see is here's the two freezers. And then the dark green one, which is the test freezer, the big test freezer, it hits the threshold. And if you can see, the next couple of readings are tan or light brown. And that means, hey, it's above the threshold. It means it's armed, if you can read the box. And then when it exceeds the 5-minute threshold, it turns red. Well, red means an alert would have been sent out. So at this point, by changing this to minus 17 for more than 5 minutes, we got an alert right here. Didn't last very long. Here went back down below the threshold. So you would have gotten a notification at the beginning saying, hey, it's above the threshold. And then you say, hey, it's back down below. Everything's fine. But now this is happening on almost every freezer cycle. So this is way too sensitive. If we go back so instead of that, let's go back and let's change that to so minus 15 for, say, 10 minutes. And we'll take a look and see. And guess what? Nothing goes above the threshold. It just hit the threshold briefly when the door was open, probably, and that's it. This is a good setup for us. So again, the key to this is using this tool based on actual data, actual temperature inside these freezers to set the right thresholds for letting you have alerts. So this really is the heart of the system, is figuring out when you want to be notified. We have defaults for the different types of freezers and refrigerators, but we think it's best after a couple days when we have actual temperature data from your freezers and refrigerators, we then can go back and fine tune this. And we do this with you. This is part of how our online training is. We work with you in your equipment and your setup to fine tune and make all these adjustments. So
let's go back to the graph for a moment, Mark, please. Because okay. What's this one?
Let's take a look. So this happened on a Sunday and at 18:01, which is 6 p.m. to 6:01 p.m. It went above the threshold and it went way up and it didn't go down. Well, it turns out there was a power failure on that Sunday, August 4th, when one of the big storms came through New York. Yeah. And there was no power for that entire period. And so the good news is the sensor kept taking the temperature every few minutes and recording it and has a complete record. And we got up to like, what is that? Minus 288, I think is the peak. So basically it got pretty close to 0 Celsius, which is like 32 degrees Fahrenheit. And then for both freezers at the same time, and then they both went down. So this is an example of being able to continuous data logging even during power outages and so forth, which is crucial for a lot of our customers. So it's like if you had medications or vaccines or something else in there, you would now know that, hey, it did get up close to freezing. Now, for certain vaccines and medications, if it gets above, usually it gets above like 5 degrees for more than some like a half hour, you may have to throw away that medication. And during a power outage, you wouldn't know until you came in. Remember, this is Sunday afternoon and evening. Maybe no one was around. You would have gotten notifications from the server. Hey, it's above the threshold. Hey, it's above the threshold. So you would have gotten all these notifications. But if possibly you couldn't get into the lab, or if you did, what do you do if you don't have a backup generator? How do you get power to these two freezers? But at least you know. So the continued logging is a key feature.
In our discussions with some of the universities, we've discovered the value of having this is also the ability to make it so that a procedure gets developed. The facilities manager, the lab people, who's going to be the one that figures out that maybe the door's open or a breaker has to be reset, because of the fact that we end up in these situations where it's a who shot John if it's just without the reporting, without the active monitoring. You don't get the benefit of having somebody actually have the responsibility of following up on it. Is
That's
that a
true.
fair statement? You
Yeah,
want to talk a little bit about that?
I think you just said it well.
Okay.
Okay, so I think one of the things that happened in a situation like this, it was a power failure. There's no generators, and this is what happened. So the question is what procedures do you have for a situation like this? Who's responsible? What action should be taken if the temperature got too high, and if let's say there's something that potentially could spoil or be like medications, they're only allowed to have a temperature excursion of so many degrees for so many minutes. And we have to make sure that for each of the medications that are stored in that refrigerator, in this case, a freezer, like maybe it was COVID vaccine. Well, COVID vaccines that are kept in a -20 freezer, what's the allowable range for that? And what procedures do you have? If it exceeds that, you're probably going to have to throw that away. And then the good news is you can document the reason you throw this away with this graph. So at any point, I can take a look at this, and if I click this here, I can download this graph in any one of these four formats. Most people do PDF or JPEG, but you can download the individual values of every single sensor reading, because we store it in either a CSV file or directly into Excel. So remember, we never throw anything away, so that there's a continuous record of all the temperatures, even during outages and so forth. So depending on your procedures, you now have a record, and it's approved federal government to CFR 21, which means users cannot modify the data or edit the data. It's read-only access. And so we certify to the federal government and other regulatory agencies that this data has not been modified by users. So that's that. All right. One of the other issues is monitoring the ambient temperature, whether it's indoors or outdoors at a construction site or in a lab or whatever. And so, again, same idea, we're going to have different thresholds for triggering this. And in this case, this was an example for if it got to 30 degrees Celsius for more than an hour, issue an alert. And if it gets to 35 degrees Celsius for more than half hour, that if it ever gets to 40 degrees for 15 minutes or more, issue that. And the idea, again, is to have these different thresholds for notifying people as the condition worsens. So in construction sites in particular, this can be worker safety is a big issue now. And there's been a lot of instances of heat stroke and people being overcome by heat, especially with the recent hot weather, and especially on a construction site. And so from a worker safety standpoint, being able to monitor this and so forth. We also have the ability to do a heat index, which is a NOAA standard that's kind of a combination of temperature and humidity, and has to do with the body's ability to cool off by sweating. And if the humidity is too high, this sweating doesn't work and doesn't really cool you off. And so even though it's maybe 100 degrees, but if it's really high humidity, then it feels just awful. and you really have to be careful. So the idea again is for being able to monitor ambient air temperature or humidity, and issue alerts based on that as well. So one of the other things is, well, how do you want to do it? So this is an internal Coris account, and we have it set up for each of these levels of problems. We're going to get an email to the Coris operations email address. But let's say we also want to get text messages. Well, I'll add a contact method, make a phone. Our phone number is 212-710-2973. And I'm going to call this Coris phone. And I'm going to save that. And now for each of these levels, let's take a look at definite. Let's say I not only want to do that, but for definite problem, I want to get a text message. So I want to get an email and a text message, both, if any time that something is considered a definite problem. And then if it's urgent, I want everything. I want a phone call as well. So I'm going to get an email, a text message, and I'm going to get a phone call. And the phone call, basically, it's a robo voice that reads you the alert twice and then hangs up. But this is really useful because a lot of times if you get tons of emails or text messages during the day, you may not pay attention, but you won't ignore a phone call. You'll know that you got a phone call. So we'll save that. So now we've now got these different types of, for possible problem, we're getting an email. For definite problems, we're getting a text message and email. And if it's considered an urgent problem, we're now getting all three. We're getting a text message, a phone call, and an email. And now we can add additional things. So if I wanted to get stuff, let's say I want to put in a landline at home, home landline phone, I can put in another phone number for that, and I could do that. And then I could say, if it's urgent, also 555-212-1212. See if that'll take that. So now, if it's urgent, I also wanted to call this home landline and make that call, because if this is really urgent, I want to make sure that I'm getting notified. And so that's the way you do it. So I think for each user, you select how you want to be notified based on the different severity of the issue of the problem that you're facing. Next thing is users. Well, right now, let's say we want account management. We just have Coris as the user. We want to add a new user. Well, I'm going to make a manager, and I'm going to do Carl Ford. And save this. And now Carl is going to get an invitation, an email. The system sent him an email saying, hey, please set up your own username and password for this account. And these are the sensors that are in the account. And I could select for him, say, hey, this small freezer, the CO2 sensor, the fridge sensor, and the big test freezer. I want to make sure that he gets notified and can see these in his account. And you see this, it went from a red eyeball with a slash to a green eyeball, which means now he's looking at these. He's able to see these inside his account. Now, the other thing is we have different categories of users, so with different roles and responsibilities. If I go down, if I scan the manual down, these are the different categories of users. And if I make that a little bigger, you can see we have administrators, managers, enhanced users, and end users. And so these are the different functions on the left. Well, end users can receive alerts, good. And number two, they can respond and take notes in an alert and let other people know what's going on. The next level up is enhanced user. They can do those. They also can suspend an alert. Let's say it's a freezer died or it's a power outage and you say, we don't need to get any more alerts. We know there's an issue. You can suspend an alert notifications from going out. And then the other thing is enhanced users can pick which devices they do. When I was showing you setting up Carl's, let's say if he was an end user, we would have set those up for him. Now, a manager is the next level up, and they basically it's like admin for adding and deleting users and so forth. They can log into other people's accounts. They can set up new accounts, and they can do all that kind of stuff. And then the final at the top is administrators. And the administrators can do everything, and they are the only ones who can either create new alerts or they can change the alert settings. So you want to limit the administrators to those people who've gone through the training session, like a longer version of this demo, and they know how the system works and so forth. So usually there's a couple people in an account that are administrators, and most of the users are enhanced users or end users, depending on the situation. The other thing you should know is reports. I mentioned reports earlier. Let's create a report. Let's call this the daily freezer report. And I want that every day. And then I want the average reading. I pick what statistics I want in that report. Yeah, I like the average reading, the min, the max. I like readings range too. I can pick as many of these as I want. You just click which statistics you want included. But I think these 4 are good for me. And then for graphs, I want to get a graph of what the temperature was in each of the freezers. And if there was any alerts that went out, any alert, then there's the tickets that go along with it. Show a graph of the beginning and the end of the alert. It's useful. Oh, what to add? Well, let's see. I want the small freezer in this case, and I want the big freezer. Just those 2. Who's receiving it? Well, of course, it's me. If we had other users in the account, I can select those other people to also get it. Save the changes. I've created a report. So let's see what it looks like. I'm going to do, you know what? I want to get this automatically. So I click this box, and now automatically it's going to, at the end of the day, it's going to generate a report to cover today automatically and send it to me. But I want to let's go back and let's take a look. Let's say the 8th, arbitrarily, pick a date. So what it's going to do for those 2 freezers, it's going to go through and get all the readings, and it's going to create the report with those graphs and those statistics. And here it is. Let me click on this, and you can see this report. It's not much of a report. It's pretty small. But you can see, remember I'd asked for those statistics. This is the average, the minimum, and the maximum, and the range. And so in this case, I picked the humidity. I forgot to do the temperature. So I've got the relative humidity here. But here we go. Here's the small freezer. This is the temperature. And here's the humidity inside the large freezer. So you can see that's what happened on that day. So this is really easy. Now, remember I said we never throw anything away. Well, this is a permanent link to this report. So if I can click and copy that link address and send it to someone, and then they can log in and they can see this report as well. I can also, it's PDF. You can download it as a PDF, and you can forward it to people or keep it. The good news is that we keep these reports forever. So if I go back in to this report thing, down on the bottom, if I click on that, hidden. Well, we've only done 1 report, but here's a record of all the reports that have been generated and their name, and I can click on them at any time. So let's do another one. Let's do another report. Create another report. We'll call this weekly fridge report. And I want these in the range for the week, but also for each day of the week, I want to get what the min and the max was, temperatures. And then I also want to know what the temperature was at, let's say, at 1 o'clock. So 1 p.m. And so there's some regulations where you have to show temperature once or twice a day, what it was. And that goes back to the early days when people actually had like a thermometer and on a clipboard, they went and they took the temperature like first thing in the morning and then last thing at night, say like at 5 o'clock or something. And they had to take those readings and log them. Well, now this is all automated. It's all included in the report. And in this case, I want to do the fridge temp sensor, save the changes. And now let's do on demand. I want to go back, not that far. Let's go back to the week starting August 1st, and let's generate a report. And let's see what goes on that report. And here it is. Let's click on it. And here's the report. And you can see, kind of boring, but that's what happened in that fridge. That's it. That's before it was put in the fridge. So let me do this again, but let's change this to, instead of the fridge, let's do the freezers again. Freezers report weekly. And now instead of that, I want to do the two freezers, small freezer temp sensor and test freezer. There it is. Test freezer. I want to save the changes. I want to generate a report. I want to go to August 1st and generate it for those two freezers. So I'm now going to generate that report. And here it's done. Let's take a look. That would be that week of starting August 1st. And look what happened. This shows the stuff, and we have all the statistics. So this is a more complicated report. So not only do we have, the average, min, max, and range, but now we have by day, starting August 1st to the 7th, we have all of those set up. So that's reports. There's some features for teams. In large accounts, you can have like a subgroup or sub account. We call it a team. You give the team a name, group A, and then you do that, and then you can pick what sensors should be in that group. So let's maybe have two locations, and you want an overall account that has everything, but then you want two different groups, one for each location, and then you just pick which sensors are going to be included for that group. Hit save, and so now there's two sensors there. We would then choose account. We'd add users to that, and so this is a useful way to set up different teams for different actions. So in some cases, having like a sub account, and that way this group, they only see the sensors and the users in their group. They don't see anything else, and then the other group would only see what's in their group. Okay. So here's just a temperature graph, ambient temperature graph, and so forth. And so in this case, it's a high threshold to be warning that it's getting really hot, 35 degrees Celsius. But what we've a couple of our customers have done is in the construction industry, there's a lot of materials that are temperature and humidity sensitive. And when you're at a construction site, materials get delivered, whether it's like millwork and custom cabinets and stuff like that, or certain laminates that use for flooring and things like that. And so the manufacturer usually says this must be kept within such and such a temperature range, not above that, not below it, and whether that's for like the laminates or the woodwork or something like that. One of our large construction customers did a big project in an office building in Stamford, Connecticut, and it was very high-end offices, and they had all sorts of custom millwork and exotic woods from South America, and it was very, very expensive. And they had about 30 or 40 of our sensors scattered around the construction site to monitor the conditions, mostly temperature and humidity. They had a couple of water sensors, but the key thing was temperature and humidity. So the construction is over, the tenant moves in, and within 6 or 8 months, some of the wood is warping. The custom cabinets and the millwork and stuff like that, and that should never happen. And so they were blaming the construction company, and the construction company was able to show for the 1 year interval where they were doing work that the temperature and humidity on site never exceeded the thresholds, either high or low, of either temperature or humidity. And they were able to show minute by minute what the actual readings were. And that way they were not responsible, so that the company, the supplier of the wood products, they were then responsible for repairing and so forth. That avoided like $1 million cost for the construction company. It's a very big deal. So this data logging capability to have a permanent record of what the temperature and humidity was at each one of those locations within the construction site, they were able to prove conclusively that they did everything necessary to store the materials at the proper temperature and humidity, so that they were not liable. So avoiding liability can be a big deal, and having this permanent record of temperature and humidity or other sensors can help avoid huge liabilities. All right. So that's, I think, a good overview. And let us know if there's any questions. Send an email to info@corismonitoring.com, and we'll be happy to answer any questions you might have. Thank you.